Okay, I am covering 3.3. Now I'm on to mole conversions. So the first thing is kind of a recap. What is a mole? So the mole is really just a unit we use to count however many particles or molecules we have. So it's really just the amount of a substance that contains the same number of particles as 12 grams of carbon 12. So we think of just like the mole as literally 1/12 of a carbon 12 atom. Okay. It's literally a similar concept to you growing up knowing that there's 12 eggs in a dozen, except for now we're looking at the chemistry aspect of it. So you always, since you were little, maybe you started baking with mom or grandma, you always knew that there was 12 eggs in a dozen. And so you needed to figure out how many eggs you needed for the recipe, right? And was a dozen enough? And so that's the same thing we get to when we get to chemistry is when we do these different chemical reactions, do we have enough? Will we have enough chemicals to do the reaction? Okay, in a lot of labs, I do this myself and then I provide you guys with the chemicals. But now you got to think about it. If you're to do your own chemical reaction, how much of that certain element or how much of that certain chemical do you need to run your experiment on your own? So it's the same idea when we're looking at concepts of Avogadro. So Avogadro, it was Amadeo Avogadro, looked at hot air balloons. He really liked hot air balloons, and he was looking at how many particles are in the hot air balloon, right? What makes up the hot air that's contained in that balloon? And so when we're looking at that, he thought maybe there was some sort of conversion factor that we can look at for this is how many particles there are in 1 mole. Well, he died, and 6 months after his death, another scientist actually came up with that number and credited Avogadro with it. He said, hey, I've looked at Avogadro's science, I've looked at his journals, I've looked at his math. This makes sense to me. Here's his number. He just was too close to the experiment to see this number. And so it ended up being that, yes, there was a conversion factor. It is 6.022 times 10 to the 23rd particles or molecules per mole in 1 mole of a substance, which is a huge number that we can't even fathom because it's so large of a number and has so many zeros behind it. Okay. And so that's the number of particles in exactly 1 mole of a pure substance. Okay. So thinking if every person living on Earth worked to count the atoms in 1 mole of an element, and each person counted continuously at a rate of 1 atom per second, it would take 4 million years for all of the atoms on the Earth to be counted. Okay? Just for 1 mole of that element. Like, how crazy is that? That is, I can't even fathom how many particles that is, right? So that's kind of where we get the number from. So we got to combine those two, the mass, right? The molar mass and the moles. And so how do we combine that? Well, we find the mass of 1 mole of a substance, and that's called the molar mass. That is also the molar mass is the same thing as the average atomic mass. So remember when I talked about isotopes, I talked about the mass being the average of the isotopes. That's really the same thing as the molar mass. So we can actually find the molar mass by using this average atomic mass number found on the periodic table and changing the units a little bit. Okay. So like I said, the molar mass of the elements is right off the periodic table. So two little keys, I guess if this was a map, and I'm going to give you the 2 key things to remember for mole to mole, I guess mole to gram to mole conversions, right? Mole conversions total is if I know the number of moles, I need to multiply the molar mass to get the mass in grams. If I know the mass in grams, I need to divide by the molar mass on the periodic table to get me number of moles. So make sure that these 2 little equations are in your notes and star them or circle them, something, highlight them, something to point them out to you. Okay. So here's kind of how they relate to each other, right? So I have to have the number of moles And I can relate that whether that's dividing by that or multiplying by that. And that'll either give me the grams. So I can start with grams and go to moles, or I can start with moles and go to grams, if that makes sense. Okay, whether I'm just multiplying or dividing by the mole, that molar mass. Okay, so we use these conversion factors to convert between grams to moles. Okay, so for example here, if I have 2 moles of helium, right, I can look on the periodic table and see that it is the molar mass is 4.008. And so I can take 2 times 4.00 and I get 8 grams of helium. Okay, if I want to know kind of backwards how many grams of helium there are, I can divide by that 4.00 and get 2 moles of helium. Okay. Now, there are some practice problems that if you would like to try that out, that is on page 85 of your book. You can do those practice problems, okay, for those. So here's some more examples I'm going over. So if I start with 2.25 moles of iron, I need to know the conversion factor. So I look on the periodic table. I see the mass of iron is 55.85. Since I start with moles and the moles have to cross out, I know that I'm left with grams. And so I take 2.25 times 55.85, and that gives me 126 grams of iron. Okay. Number 2, I have 0.375 moles of potassium. I look on the periodic table, so I'm going moles to grams, so I'm still multiplying. The moles have to cross out or cancel out. Okay. So the mass of potassium is 39.10, and so I multiply that. So 0.375 times 39.10 gives me 14.7 grams of potassium. On to number 3, I have 0.0135 moles of sodium. I find sodium on the periodic table. It is 22.99 grams per mole. The moles have to cross out, so I know I'm multiplying. So 0.0135 times 22.99, that gives me 0.310 grams of sodium. Number 4, I start with 16.3 moles of nickel. I look on the periodic table. It's a transition metal. Nickel has a mass of 58.69. So I know that I am yet again multiplying to cancel out the moles, and I have 957 grams of nickel. If you need to take notes and I'm going too fast, please pause the video. All right, so number 1, now we're going backwards. I now have grams and I need to find moles. So I have gram to moles, we always divide. So if I know I have 5 grams of calcium, I then find calcium on the periodic table. The mass of calcium is 40.078. So I'm going to round up that to 40.8. Okay, 40.08. So then I divide 5 grams by 40.08, and I end up with 0.125 moles of calcium. You just plug that into your calculator, and you come up with that number, and that is in moles. Number 2, 3.60 times 10 to the negative 5th grams of gold. That is AU for gold. I look up gold or AU on the periodic table. It is also a transition metal. The mass of that gold is 196.97. So I take 3.60 times 10 to the negative 5th. Now in your calculator, you have to use parentheses. So the way I type this in is parenthesis. 3.60 times 10, and my calculator has like a little arrow up button to the left-hand side, arrow up to the negative 5, parenthesis, divided by 196.97 equals, and my calculator comes up with 1.83 times 10 to the negative 7 moles of gold. Okay, if you try that on your calculator, you do not get that, please come see me so I can show you And maybe you can show me what you're doing so I can correct that. All right, next is I have 0.535. Okay, that is grams of zinc. So then I find zinc on the periodic table. And the mass of zinc is 65.39. Okay. And I get 0.008 moles of zinc. And so I've turned that into scientific notation, which is 8.18 times 10 to the negative third. You can write it either way as your regular or scientific. So either you're going to have 0.008 or 8.18 times 10 to the third. All right, then we move on to Avogadro's constant. So if I know how many atoms I have and I need to find how many moles, I just divide, okay? So in this case, I'm using that 6.022 times 10 to the 23rd. Please memorize that, all right? But I know that I have 3.01 times 10 to the 23rd grams, right? Or atoms of Ag. And so I actually have to divide that by 6.022 times 10 to the 23rd, which is Avogadro's constant. So remember when you're typing this into the calculator to use your parentheses. So I literally have parenthesis 3.01 times 10 to the 23rd. So I do arrow up to the 23 parenthesis divided by parenthesis 6.022 times 10 to the 23rd equals, and I do parenthesis equals, and I get 0.49999. So I've rounded that to 0.500 moles. Okay. Then my second example here, I have 1.20 times 10 to the 8 atoms of copper. Okay. And I need to, yet again, I'm starting with atoms and I need to figure out how many moles, and then I have to figure out how many grams. So this is a 3-step problem pretty much, okay? Because I can't skip steps. So what I have to do is I have to go from atoms to moles and then moles to grams, okay? So here I have 1.2 times 10 to the 8th atoms divided by 6.022 times 10 to the 23rd. So I'm going to start out on my calculator with parenthesis 1.2 times 10 to the 8th power, so arrow up to the 8th, parenthesis, divided by parenthesis 6.022 times 10 to the 23rd, parenthesis, equals, and I end up with 1.99, and that's moles. So I'm almost at 2 moles of this atom of copper, right? 2 moles of copper. Now I need grams. So now, since I'm going moles to grams, I have to multiply by the molar mass. And if I look on the periodic table, I see that the copper's mass is 63.55. So I multiply that 1.99 times 63.55. And my answer now is 1.266 grams. Times 10 to the negative 14. So I actually have 1.27 times 10 to the negative 14 grams of copper. Okay. Very, very small amount of copper. Extremely small amount of copper. Okay. So if you want to do extra on that for Avogadro, you can do problems 2 through 6 on page 87 in your book. Okay. And so here's the vocab you should know as of chapter 3. And of course, at this point, we should have done the bottom one, mass to moles and moles to mass calculations. And also, you should know Avogadro's constant and how to do those mole conversions with Avogadro's constant. All right. If you have any questions, please talk to me when we are in class. I can show you on the board.